All right, so this video is going to go over pages 25 and 26 in your Kinematics 2 packet. Okay, so what we're doing now is we're still doing the same kind of Daffy T, the 5 kinematics equations, but now we're just adding acceleration due to gravity. Okay, so gravity causes all objects to continually accelerate towards the center of the Earth. Okay, that's pretty easy. Basic third grade science on that one. Regardless of mass, all objects accelerate at the same rate. Now it says as long as air friction is not significant. We're not worried about air resistance in these problems. We're just focused on basic physics. Okay, so what basically that means is no matter the size, gravity will affect it the exact same rate. Okay, what happens is there's a video that you can look up where they actually take out, they use a vacuum to take out all the air in a room. Okay, so they create basically a vacuum sealed room where they drop a bowling ball and a feather at the same time. Okay, and they hit the ground at the exact same time. So normally air resistance would stop that feather from falling at the same rate as the bowling ball, just because the feather is more susceptible to that air resistance. Okay, so but for these problems, acceleration, gravity is always going to be the same. So at the surface of the Earth, the acceleration due to gravity is accepted to be 9.8 meters per second squared. Now, when we're using our calculations, remember gravity is always pulling us down. Okay, so the way we're going to tell that it's down is we're going to say it's negative 9.8 meters per second squared. Now, if you forget that sign, a lot of times it won't really do much to your answer. Okay, now you won't get the full credit for it. Okay, but usually numerically your answers will be the same except for a couple examples, and we'll kind of see those here in a second. Okay, but that sign will cause some issues later on if all of a sudden now you have a negative time. Well, we can't have negative time, so you need to go back and check, was your gravity or your acceleration sign negative? Or what if you need to take a square root of a negative? Well, you can't. Okay, so because you left off that negative, it kind of leads you down into that kind of dead end. Okay, so just be careful of that. Just know that when we're doing our calculations, it is negative 9.8 meters per second squared. So which means down is negative. Okay, gravity's pulling us down, and up would be positive. Okay, other facts about free fall. Objects thrown upward will decelerate. So that means they're just going to slow down until they come to rest at the top. So that means if I throw something in the air, the highest amount of velocity it's going to have is when it leaves my hand. When it goes up, your velocity is going to get lower and lower and lower until it stops, and then it starts to fall back down, so it's going to accelerate when it's falling back down. Okay, so when that object reaches the top of its trajectory, your velocity is going to be 0, okay, because you had to stop, and then you're going to fall back down. But even though my velocity is 0, my acceleration is still going to be negative 9.8 meters per second squared. This will never be 0. It'll always be the same. Okay, it's the reason why that velocity went to 0 in the first place. If that wasn't there, if acceleration wasn't there to slow it down, it would just keep going and never stop. Okay, so in reality, objects reach a velocity where the air resistance force equals the force of gravity, and they no longer gain speed. So basically what happens is you have gravity pulling down, and you have air resistance going up, and they basically will cancel each other out at a certain point where you're no longer gaining speed. So this is called terminal velocity. And I've been using this example in class is like when you go skydiving, that initial rush is when you fall out of the plane because you're not falling, and now all of a sudden you're falling at a very fast rate. What happens is as you're falling, you're approaching that terminal velocity, which means you're not going to keep speeding up and speeding up forever. You're eventually going to reach a max velocity that's the fastest you're going to go, and you no longer feel like you're falling. Okay, so now what we're actually going to do is we're going to do a little bit of a drawing here. So I'm just going to show if I throw something up in the air, here is my path of trajectory. So if I launch something up, my velocity is going to be positive. Acceleration is going to still be negative 9.8 meters per second squared. Now at the top, my velocity is going to be 0 because I had to stop. And my acceleration is still going to be negative 9.8 meters per second squared. And when I reach the bottom, my velocity is going to be negative, and my acceleration is still going to be negative 9.8 meters per second squared. Okay, so that's just kind of showing you how gravity is not changing. Now, we're going to do some examples. So example of bullet is fired upwards of the velocity of 125 meters per second. Now in class, what I've been doing is I've been talking about how we cannot forget that these equations are there. Okay, so v equals d over t, and acceleration equals change velocity over time. Now, what you need to do is you need to figure out what do you have and can I even use those? If I can't, then I need to set up the Daffy T. So a bullet is fired upwards with a velocity of 125 meters per second. Well, to what height will it rise? So that means I'm looking for displacement. Now, this one, v equals d over t, I do have a velocity, and I am looking for d, but I don't have time. So I couldn't use that, couldn't solve for anything. Here, acceleration, well, they don't really tell me acceleration, and they're not looking for it. Now, you could probably throw in gravity if you want to, since we're talking about something falling. Okay, let's just say we do have that. Okay, velocity I do have. Okay, but time, I'm not looking for time. I'm actually looking for distance, so this wouldn't work either. Okay, so I just want to make sure that you don't forget those equations are there. Okay, it's just if you can't use those, we're just going to do is we're going to set up our Daffy T. So dA, VF, VI, and T. So what we're going to do is we're going to figure out what is our question mark. To what height will it rise? That means I'm looking for my displacement or distance. Okay, I shot the bullet up with a velocity of 125 meters per second, so that's your initial. Okay, if you said that your initial is 0, then the bullet wouldn't even go anywhere in the first place. It's got to have that initial velocity to go up. Okay, now, to what height will it rise? So that means when it gets to the top, it's got to stop, which makes your V final 0 meters per second. Acceleration, that is due to gravity, so now we can go ahead and plug that in. Okay, so anytime it's a free fall problem where we throw something in the air, drop something where gravity's acting on it, all you gotta do is just plug in that negative 9.8. Now, if I have a car like driving down a road, so here's my car driving down the road. Okay, I know that wasn't a great car, but just for the sake of this, I'm not falling or anything, so I'm not gonna worry about using gravity. Okay, so I can have something different than 9.8, and that's totally fine. But as soon as you start throwing something or dropping something where gravity is making it go towards the ground, okay, that is when you can throw that negative 9.8. That means we did not care about time. Okay, so remember, if you're going to go back to your equation sheet, okay, we're not going to use the equation that's associated with displacement. We're going to use the one that's associated with time, the one they did not mention. So you'd use that fifth equation, so VF squared equals VI squared plus 2AD. Okay, so what we're going to do is we're going to plug in now. So 0 squared is going to be 0. VI is 125, and that's squared, plus 2 times negative 9.8 times distance. Now, what I would do now is I would bring that 125 squared over to the left side, which is going to make it negative. So that's negative 15,625 equals negative 19.6D. Now, this is where if you left off that negative sign on the 9.8, it's not going to really affect your numerical value. It's just going to tell you that you're going to have a negative distance. Well, if I'm shooting something up in the air, I shouldn't have a negative distance. I should have a positive distance. So that's where that negative kind of comes into play to balance out, because if I divide both sides by 19.6 and negative 19.6, those negatives are going to cancel out, and we're going to get a height of 797 meters. 797.19 meters. So there's your answer right there. Okay, B, how long will it take to reach the height? So that what we're going to do is we're going to go set up our Daffy T again. Okay, so our distance, not looking for that anymore. Okay, so we're just going to leave it blank for right now. A is going to be negative 9.8 meters per second squared. VF is going to be 0 because at the top you've got no velocity. VI is still going to be that 125 meters per second. Now, could you have used the 797.19 meters from part A? You technically could have, but there's a couple reasons why I don't use it. Is one, I like to use the automatics that they give us. Like, I'm not going to mess with that 125. I'm not going to mess with that. I know that VF is 0, and I'm not going to mess with gravity. Okay, so I'm not going to get rid of one of those things to bring in something from part A. Also, if you messed up in part A and you bring that down to the next part, that's just going to create a domino effect, and it's going to mess up part B. So we're looking for time now, so that means now we don't care about distance. So that's where our line's going to go. So we're going to use equation number 1, so VF equals VI plus AT. So VF is 0, VI is 125 plus A, which is negative 9.8 times T. Okay, I would bring that 125 over the left side, makes it negative. Negative 125 equals negative 9.8 T. So divide both sides by that negative 9.8, and you get a time of 12.76 seconds. Okay, how long will it take to strike the ground again? So this you don't have to do a whole lot of math for, is we just found out how long it takes to get to the top. Okay, so it took 12.76 seconds to go to the top. Okay, so which means if we don't lose energy anywhere, and we're not, okay, because we're getting rid of air resistance and all that, it should take the exact same time to go back down. Okay, so that would technically be my answer, is how long would it take to go to the ground again. Now, if I asked how long was it in the air, all I'd have to do is just take that 12.76 plus 12.76, and you get 25.52 seconds. Okay, so there's multiple things I could have asked there. So that's how you would do both of those. So one, you just got to know whatever time it takes to get to the top, it's going to be the exact same going back down. And if I want to know what was the total time in the air, all you got to do is take that time you found in part B and just multiply it by 2. Okay, D, what is the velocity after 18 seconds? What I'm going to do is I'm going to set up my Daffy T. Now again, like I've told everybody, is if you use another equation and you get to the exact same answer, okay, that's fine. There's multiple ways to solve things. There's not always going to be just one way. Doesn't matter to me. As long as we get to the same answer and you can kind of repeat those results, then that's fine with me. All right, so what is the velocity after 18 seconds? So my time is 18 seconds. Initial velocity is still 125. Okay, my V final I don't know. That's what I am looking for. A is still negative 9.8. That means we did not care about distance. So we're going to use equation number 1. So VF equals VI plus AT. Okay, so VF, don't know, leave it as VF. VI is 125 plus A, which is negative 9.8, times your time, which is 18. Now, this right here is where you got to be careful, is if you leave off that negative symbol, that is going to give you a big difference in your answer. Because if you take 125 plus all that, okay, then that's a lot bigger difference than 125 minus that. Okay, so that's just where you got to be careful. So 125 minus all that, and you're going to get a velocity of negative 51.4 meters per second. Okay, or you could say 51.4 meters per second down. But the whole reason it is negative is that means it's already reached the top and it's on its way back down. Okay, so at 18 seconds, it's already reached its max height, and that means at 18 seconds, it's already on its way back down, and it's going negative 51.4 meters per second down. Okay. E, what is the velocity? What velocity will it strike the ground with? So remember we talked about we're not losing energy anywhere. We're not worried about air resistance. So whatever velocity I shoot that thing up with, uh-oh, my pen's breaking. All right, so my pen's breaking on this one, so I'll just kind of explain this one. So whatever velocity going up is going to be the same velocity going down. It's just going to be negative. So you have 125 meters per second going up. So whenever it comes back down and hits the ground, it's going to be a negative 125 meters per second. Okay, so hopefully that video kind of helped. And then the next video, we're just going to do more practice over just free fall stuff. And then that last video is going to be the review.